Okay, so for the Chapter 8 screencast involving the bungee jumper, um, for a bungee jumper who wants to just touch the water at the bottom, for a bungee jumper that's 66 kilograms and the jump height is 150 meters, and he's using a cord that's 50 meters long, unstretched, and we're going to figure out what the spring constant of the bungee cord would have to be. So first what we want to do is find his kinetic energy at the point where the cord is about to become taut, like perfectly taut. So that would be at h equals 100 meters since the cord is 50 meters long. So his kinetic energy at that point, which also equals the work done, will just equal the potential energy due to gravity initial minus potential energy due to gravity final, which equals 32,340 joules. So the person has 32,340 joules of kinetic energy just before the bungee cord becomes taut. So at that point, the kinetic energy is going to equal the negative work done by the spring throughout this whole 100-meter stretch here that the spring is going to stretch. So kinetic energy final, which we just calculated, is equal to the negative work done by the spring, which equals 1/2 kx squared. So negative 32,340 equals 1/2 k times this 100 meters here squared. And turns out the spring constant would have to be negative 6.47 Newton meters. So a person who is wishing to jump from a 150 meter high bridge, who has a mass of 66 kilograms, using a cord 50 meters in unstretched length, the cord would have to have a spring constant of K equals negative 6.47 Newton meters.